My dear students, in my previous videos, I have solved some problems in the exercise number 12.2, mathematical logic. Using truth tables, we have solved some problems in the exercise 12.2. Now I am going to continue the same exercise in this video also. Before continuing the exercise, I am going to recall the four fundamental important truth tables. These four important truth tables are very much used for solving the problems. The only four fundamental truth tables are very important for constructing the truth tables in the exercise problems. First one is conjunction, symbol, cap notation. P and Q are two different statements. P conjunction Q. In the conjunction table, if both the P and Q are T, the truth value is T. Otherwise, the truth values are F. Both are T only, the truth value is T. Otherwise, truth value F. This is conjunction table. Similarly, disjunction, inverted cap. P and Q are two different statements. P disjunction Q. In this case, both P and Q are F, the truth value is F. Otherwise, the truth values are T. If both are F, truth value is F. Otherwise, both are T. Any one of it T is T. Now, all the three are T in the case of disjunction. In the case of conjunction, both are T, only T. Otherwise, all the three are F. These two are conjunction and disjunction. Next, if P then Q. If P then Q. So, single condition statement. If P then Q. In this case, P and Q are two different statements. If the first statement P is truth value is T and the truth value of second statement Q is F, T to F is only F. Otherwise, all the remaining three are truth value T. If first the statement P is having truth value T and the truth value of the statement Q is F, if T tends to F is F. Otherwise, T tends to T is T, F tends to T is T, F tends to F is also T. So, single condition statement, if P is T, Q is F only, truth value F. Otherwise, the remaining three are truth value T. If and only if P, then Q. That is, P if and only if Q. If and only if P then Q is, that is, if and only if means biconditional statements. That is, P consisting of truth values, P and Q are two different statements. In this case, for biconditional statements, both are T and both are F, truth value is T. Anyone is T or anyone is F, the truth value is F. That is for biconditional statement. Both are T, truth value is T. Both are F, truth value is T. So, these four different truth tables are very fundamental truth tables, which are very much useful for solving the problem. These are the basic fundamental tables. Now, I am going to continue the exercise 12.2. We have solved some 7 problems in the exercise 7.2. In the 7th problem, 4th subdivision, we are going to see now. In the exercise 12.2, 7 problems we have solved so far in our previous videos. In this video, the same exercise, exercise 12.2. In the exercise 12.2, problem 7, 4th subdivision. Verify whether the statement is tautology, contradiction or contingency. The statement is, if P then Q, if P then Q conjunction, if Q then R, if P then Q conjunction, if Q then R, this is tends to single condition, if P then R, if P then R. See, we have to verify whether this statement is tautology or contradiction or contingency. Now, P and here we have P, Q and R, three different statements. Therefore, we have 2 power 3, 8 rows in the truth table we have. For that, the first P consisting of 4 T's and 4 F's. Since it is statement consisting 3 variables P, Q and R, we have 2 power 3, 8 rows in the truth table. 4 T, 4 F. Q is 2T and 2F alternatively. 2T and 2F alternatively. This is Q. Next one, R. R is T and F alternatively. T, F, T, F, T, F. Like that, T and F alternatively we have for R. Next, if P then Q. If P then Q. For single condition, if P then Q, if the first statement P is true, the second statement Q is R, then only the truth value is F, otherwise truth value is T. If P then Q, T to T is T, T to T is truth value T, T to F, if P is T, Q is F, then T tends to F is F, T to F, F to T, truth value T, F to T, truth value T, F to F, truth value T, F to F is also truth value T. The only case P is T, Q is F, then only the truth value is F, otherwise T. Next, if Q then R, if Q then R, if Q then R, T tends to T, T tends to F, F, because first statement T, second statement F, then T tends to F is F. F tends to T, T, F tends to F, T, T to T, T, T to F, F, F to T, T, F to F is also T. This is Q tends to R. The next one, P tends to Q, P tends to R, we will write. P tends to R. P tends to R. P to R. P tends to R. T to T. Truth value T. T to F. Truth value F. T to T. Truth value is T. T to F. Truth value F. First statement T, second statement F is truth value F. T to F. F to T, T, F to F, T, F to T, T, F to F is also T. Now we want P tends to Q, conjunction Q tends to R. P tends to Q, conjunction Q tends to R. That is, P tends to Q, Q tends to R. For these two columns, we want conjunction. Conjunction means if both are T, truth value is T. One is T, another is F, the truth value is F. For conjunction, both are T, only T. FT, conjunction F. FT, conjunction F. Both are T, conjunction T. Anyone T, F. Both are T, conjunction T. Both are T, conjunction T. P tends to Q and Q tends to R. Conjunction is T, F, 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 T, F, T, T. Next records then this statement and Q to R. Q tends to P tends to R. That is, here I write P tends to Q, conjunction Q tends to R, that tends to P tends to R. That's we want. Here. This is our required column. P tends to Q, conjunction Q tends to R is this, and P tends to R is here. We want the P tends to Q, conjunction Q tends to R to P tends to R. From this single condition, from P tends to Q, conjunction Q tends to R to P tends to R, that is T to T, truth value T, F to F, truth value T, F to T, truth value T, F to F, truth value T, single condition, T to T, truth value T, F to T, T, T to T, T, T to T, T. Since all the entries in the final column are having truth value T, therefore the given statement is a tautology. That's all about the problem solved. Since all the entries in the final column having a truth value T, therefore the given statement is a tautology. Complete the problem. Therefore, problem is, therefore P tends to Q, conjunction Q tends to R, tends to P tends to R is a tautology. Is a tautology. That's all about the problem. It is a tautology. The final column consisting all the elements of T, therefore the given statement is a tautology. That's all about the problem 7. Next we will go to the next problem 8. Next, problem 8 is in the exercise exercise 12.2. Problem 8 is show that negation of P conjunction Q, negation of P conjunction Q is equivalent to negation P, disjunction negation Q. That's all about the problem. Negation of P conjunction Q. You know, P is T, T, F, F. Because two variables, we have to go to 4 rows only, and Q is alternatively T and F. P conjunction Q. P conjunction Q, both are T, conjunction is T, otherwise F for conjunction, both are T. Next, negation of P conjunction Q, negation of this, that is negation of P conjunction Q. Negation of P conjunction Q is T is replaced by F. F is T, F is T, F is T. So T, F, F, F is F, T, T, T. That is negation of P conjunction Q is F, T, T, T. Next we want negation P. Negation P, F, F, T, T. T, T, F, F replaced by F, F, T, T. This is negation P and negation of Q. Negation of Q is Ft. Tf is replaced by Ft. 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 T is replaced by F. F is replaced by T. Next, disjunction for these two columns. we want negation P, disjunction negation Q. Disjunction means if both are F, truth value is F. Anyone is T, truth value is T. T, both are T, T. See, negation of P, conjunction Q is F, T, T, T. Negation P, disjunction negation Q is F, T, T, T. Therefore, these two are same. Negation of P, conjunction Q and negation P, disjunction Q are columns are same, truth values. Therefore, the given statement is true. Therefore, negation of P conjunction Q is equivalent to negation P, disjunction negation Q is true. Proved. Alright. Proved. That's all. Next problem, the second subdivision. In the eighth problem, second subdivision we are going to see. Show that eighth problem, second subdivision, show that negation of P tends to Q, single condition, negation of P tends to Q is equivalent to P conjunction negation Q. See here also the column P and Q are same. Next we want P tends to Q. For this column, instead of P conjunction Q, I want P tends to Q. That column is P tends to Q. P tends to Q, no. T to T is T, T to F is F. Otherwise F to T, T and F to F is also T. For single condition, T to T is T, T to F is F, F to T, T, F to F is also T. This is if P then Q. Next, negation of if P then Q. Negation of if P then Q. We want a negation of P if P then Q. For this statement we want negation of this thing. T is F, F is T, T is F. These two are T is F, F is T, negation, T is F, T is F. This is negation of P tends to Q. Negation of if P then Q is this. And the next one, negation Q we want. We don't want negation P, but we want negation Q. Negation of Q is here. The same column F, T, F, T. Negation of F, T, F, T, F, T, F, T. This is negation Q as it is, right? Next, P conjunction negation Q. Next column, we want P conjunction negation Q. P conjunction negation Q. For these two, we want conjunction. Both are F. Conjunction is F. Both are T. Conjunction is T. Sorry, P conjunction. P conjunction negation Q. T negation F. T conjunction is T and F is F. T to T. T conjunction T is T. F conjunction F is F. F conjunction T conjunction F, F. T conjunction T, T. F conjunction F, F. F conjunction T is also F. See, F, T, F, 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 T, F, F. See, the column P conjunction negation Q and negation of P tends to Q are one and the same. F, T, F, 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 T, F, F. Therefore, the given statement is also proved. The columns negation of P tends to Q and P conjunction negation Q are same. Therefore, negation of P tends to Q. Negation of P tends to Q is equivalent to P disjunction negation Q is proved. Is equivalent to P conjunction negation Q is also proved. This is eighth problem, second subdivision is proved. Okay. Next, one more problem we will see. Ninth problem, simple one, and we will see ninth one. Show that it's also like the same type of eighth one. Ninth problem, show that Q tends to P. Q tends to P is equivalent to negation P tends to negation Q. P, Q are here. Q tends to P we want. Here we want Q tends to. P, Q are same. Next we want Q tends to P. If Q then P. If Q then P. If Q then P. Q to P. T to T. T. F to T. T. T to F. F. F to F is also T. T to F only F. This is Q tends to P. T to T. T. F to T. T. T to F is F. F to F is also T. Q tends to P. Next, negation P. Negation P. Negation P is T is replaced by F and F is replaced by T. This is negation. This is negation Q. Already we write this is negation Q. Negation Q is T. F is replaced by F. T. F. T is F. T. T F. T F is F T. F T. T is replaced by F. F is replaced by T. So this is negation Q. Next, negation P tends to negation Q. For these two statements, negation P, then negation Q. If negation P, then negation Q. That is negation F to F. Negation P. If negation P, then negation Q. F to F is T. F to T. T. T to F is F. T to T is T. See the column. Q tends to be T, T, F, T, 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 F, T. The Q tends to P is T, 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 F, T. So here also T, T, F, T. This is also Q tends to be is T to T, F to T, T, T to F is F, F to F is C. T, T, F, T. T, T, F, T. T, T, F, T. T, T, F, T. So, columns Q tends to P and negation P tends to negation Q are one and the same. Therefore, the given statement is proved. Q tends to P is equivalent to. Therefore, Q tends to P is equivalent to negation P tends to negation Q is proved. Negation P tends to negation Q is also proved. That's all about the problem 9. So we will stop here. The 10th problem we will continue in the next video. Thank you.